So question 4 in 2.3. 2 cards are drawn without replacement from a well-shuffled standard deck of 52 cards. And we've got 3 parts here. What is the probability that the second card drawn is an ace if we know the first card drawn is an ace? B, what's the probability that the second card drawn is the ace of spades, given that the first card was an ace? So now we're being a little more specific. C, what's the probability that the second card drawn is an ace if we know that the first card drawn was a king? Okay. So all of these are conditional probability questions. It makes sense. 2.3, conditional probability questions that we should be looking at. Okay. Now, there's sort of 2 ways we could go about this. There's sort of the longer calculation route and the sort of faster where am I currently sitting at with my deck of cards method. So maybe we'll show both of them off. So A here, probability of second card drawn is a spade, given that we know the first card, or sorry, first card is an ace. Second card is an ace, given that the first card was an ace. Okay. We could make sort of nice events. We might say let F be the event the first card is an ace. Okay. And maybe S the event the second card is an ace. And what do we want? We want the probability that that second card is an ace if I know that the first card is an ace. So I know F has happened. What are the chances S has also happened? Okay. Now, how could we handle something like this? Well, we've got a formula. We figure out the probability of both F and S happening, divided by the probability, okay, of just my known event, F, happening. And then we say, all right, well, I've got to work out these probabilities here. Now, because we're dealing with sort of a deck of cards, same sort of thing that we might have talked about in Chapter 1, we can actually treat this as an equiprobable sample space version of conditional probability. And you might remember there's a shortcut with that. Rather than having to work out n of this over n of the whole sample space, which I probably shouldn't have used S, but we'll say U for universal sample space. Okay. And then this as well. You know, we'd have to break each of these down into 2 counting problems. The nice shortcut when it comes to equiprobable sample spaces and conditional probability is that we don't have extra problems to do. We just need to figure out the number of ways that we can get the first and second cards to be aces, divide by the number of ways that just the first card can be an ace. Okay? So those are 2 smaller counting problems. So we'll do n of F first. So number of ways to get the first card as an ace. Okay. So now I think about, well, I'm drawing 2 cards from the deck. I'm going to go ahead. I'm going to get my first card. And so I need it to be an ace. So there's 4 aces to choose from. I just need to pick one of them. So pick one of those 4 aces. And then, what do I have left? Well, I've got 51 cards left in the deck. It can be any of them. Okay. So 51 cards left to pick from. This is 4 times 51. Notice that there sort of is an order. We are talking about a first card and a second card. So it's not just choosing. It's first I pick my first card, then I pick my second card. Okay? And so there is a difference between if I get the ace of hearts first and then the ace of diamonds. That's different than picking the ace of diamonds first and then the ace of hearts. Okay? There's some order to our choosing from the deck, because they are specifically in this question talking about a first and second card. Alright, so that's the number of ways to just get the first card guaranteed to be an ace. You narrow it down to, I'm just picking from these 4 aces. Okay. How about getting the second card and the first card to be aces? How many ways are there to do that? Well, pick your first card only from the aces. That guarantees that it's an ace. Well, there's 4 of those to choose from. And once I've chosen one of those 4 aces, how many aces are left in the deck? All right, we pick out the ace of clubs. Okay. I can't pick that again, but I need my second card to be an ace, so there's 3 of them left. So 4 times 3, and that's the number of ways to get both of them to be aces. Okay, so the probability of getting the second card as an ace, given that the first card is an ace, is 4 times 3 over 4 times 51. But the 4's cancel out. We get 3 out of 51. Okay. So that's one way to do it. But just to show off another way to do it, you could instead say, okay, let's suppose we're in that situation. I've already drawn my first card, and I'm just more interested in what's the second card. Okay? I know the first card is an ace, so when I think about the deck, so sort of imagine first card was an ace. Right? When I imagine the deck, what's left? Well, there were 52 cards, but I took out one ace. So 51 cards in the deck. And specifically, because I removed one ace, we have only 3 aces left. Okay. So if I think about it this way, I could reason my way to saying, well, what's the chances my next card, my second card, is going to be an ace? Well, there's only 3 of them left, and there's only 51 cards in the deck left. So 3 out of 51. And you can work at it that way. Okay. Same answer, different reasoning, a little less calculation. Okay. But there's A all done. How about B? So what was the probability second card drawn is specifically the ace of spades, given that the first card drawn was an ace? So again, you could approach it either way. Okay. But, well, we need the second card drawn to be the ace of spades. How many ways are there to do that? So maybe make events. So we'll say, let's say F, first card ace. Now, is that really all I need? Right? We're assuming the first card was an ace, but we're interested in the second card being the ace of spades. Maybe we'll call it P for spades. So what do we want? We want the probability that we get the second card being the ace of spades, given that we know the first card was an ace. And again, we know how conditional probability works. We've got that formula all set up. Right? But again, equiprobable sample space comes into play, and we just do 2 counting problems. And we already know the answer to one of these. 4 ways to draw an ace. And then, who cares, pick one of the remaining 51 cards for the second one. So we already know what the bottom is going to be. Okay. So what is the number of ways of drawing an ace second? So drawing ace of spades second. Okay. And here's where it might be a little tricky. Because the number of ways of drawing that ace of spades second, the first card definitely has to be an ace, because it's ace of spades second and first card is an ace. But when it comes to picking my first card, I don't have 4 choices. Because what if I choose the ace of spades? Then how am I going to pick the ace of spades second? It doesn't work that way. So start with what you know. I know for a fact that I have no choice. That second card has to be the one and only ace of spades. So my first card, it has to be an ace, but it has to be one of the 3 other aces. It has to be ace of hearts, ace of diamonds, or ace of clubs. So in fact, there are only 3 ways to pick an ace first, and then have the second card be the ace of spades. Okay, and so that gives us a probability of 3 over 4 times 51, which, we could say is 3 over 204 if we really wanted to, but I'd probably leave it like this. Right, so it's a little harder because of this. We want an ace, but knowing that we have to have that ace of spades second sort of ruins the count a little bit. Okay? And now C part here. What is the probability the second card drawn is an ace, given that the first card drawn was a king? Now, if this was with replacement, this would be an example of sort of independent events. Knowing that I got a king, and then I took my king, I shuffled it back in the deck, tells me nothing about getting my ace. But since it's without replacement, let's walk ourselves sort of through what's going on here. So we'll have event K. First card is a king. A. Second card is an ace. We want the probability of getting an ace second, given that the king came first. Always put your known event down below. But again, based on the language of the question, equiprobable sample space, just trade it for 2 counting problems. And we wouldn't be able to do this if it was some sort of more stacked deck or something like that. We'd have to do a lot more clever work, but we can just, in this case, trade it for 2 counting problems. So, number of ways to get a king first. So, number of ways to draw 2 cards with a king being drawn first. Well, think about the 2 cards you draw. 4 kings in the deck. Pick one of them. That leaves me with 51 cards in the deck. Okay, pick another one. Doesn't matter what it is, whether or not it's a king or an ace or whatever. Pick any one of those 51 cards. Okay, now how about the top? So this will be get a king first and get an ace second. So think about the cards that we can draw. Okay, we've got 4 kings in the deck. Got to pick one of them. And then, for my next card, pick one of the 4 aces. And there are 4 aces left over, unlike previous situations. Okay. So the probability of getting an ace second, given that you got a king first, is going to be this 4 times 4 over the 4 times 51 that we just worked out. 4 out of 51. And again, if you wanted to, you could just talk your way through it. Like, imagine that I just drew a king from the deck. Hey, how many cards are left? 51 cards. How many of those are aces? 4. 4 out of 51 is the chance I'm going to get an ace on my second draw.